Hello friends, just I am going to discuss what is the machine learning and how do we use a machine learning with a Spark, PySparks. So it's a machine learning I have already discussed like a machine learning with PySpark, Python Spark. So it's a PySpark is the really Spark is the really fast than the other tools. So what is the machine learning? It's a mechanism through which we try to make a machine learn without explicitly programming them to do so. So we showcase the machine a lot of picture or cards and dogs just enough for machine to learn the difference between the two and recognize the new picture correctly. So there is number of the questions has been written, but the questions here might be like what is the need of so many pictures to learn something as simple as differentiating between cats and dogs. So the challenge that a machine faces is that they are able to learn the entire pattern or abstractions features just from a few images. So they need to different in the some ways and to learn the many features as possible to be able to make a right prediction. So whereas humans and we have this amazing ability to draw abstractions at a different level and easily recognized object. So many differences. You can see that there is a ton of definitions of machine learning on the internet, but I could try to put in simple terms machine learning is using a statistical techniques and sometimes advanced algorithms to either make a predictions, to learn a hidden pattern within the data, and essentially replacing a rule-based terms to make a data-driven systems more powerful. So it's a machine learning, as name suggests, is making a machine learn through there is the many components that comes into a picture when we talk about making a machine learning. So there are different types of the machine learning. It's a different type of the machine learning. So different types of it's a machine learning. One is the supervised machine learning. Supervised machine learning, and second is unsupervised. I will describe each and every one, don't worry. Supervised ML and semi-supervised. It's a semi-supervised machine learning and a reinforcement learning. It's the fourth is the reinforcement learning. right? It's a 4 types. So today we are using actually, so what is the it's a means purpose of this, like a first we categorized and is used a specific purpose. So the data is the most important if you are applying any types of the machine learning. So these are the major categories, but whenever we used like a different forms of the machine learning, so we will learn at the end of the day. Machine learning is learning from a data, like a data might be a historical and or a real times, and making a decision offline or real time based on the modeling training. So first try the like a supervised machine learning. What is the supervised machine learning? So it's a this is the prime category of the machine learning, and that divides a lot of the applications and values for a business. So supervised machine learning means we train our model on the labeled data. By labeled means having a correct answer or outcomes of the data, and then we will try to understand like a suppose we have a financial company, and that if there is a financial company and that wants to filter customers based on their profile before accepting their the loan request, the machine learning models would get trained on historical data, so which contain information regarding a profile of the past customers, and label column if a customer has defaulted on a loan or not. The simplest data will be we can try to understand. So let's like something. Okay, it's a first is a supervised machine learning. So like suppose I have customer details, like example we can see here. Example, a customer ID, customer it's a ID, like a customer age, it's a gender, and it's a salary, it's a number of loans, and job type, and loan default. It's a loan default. Right. So it's a customer ID like a ID 23, age like a 32, it's a gender like a male, it's a salary like a 80,000, it's a number of loans is the 1, job like a permanent, and loan default is no. This is the data. So in the supervised machine learning, the model learns from the training data, and that had labeled outcomes target columns, that is used this to make up predictions on unseen data. So in this example we will see the columns such as age, like a gender, and salary are all known like a attribute or features. So where the last column loan default, like a loan default, this one loan default is known as a target or label the models try to the predict for unseen data. So one complete records with all these values is known as observations, and the model would require a sufficient amount of observations to get a trained and then make a predictions on a similar kind of data. So there needs to be at least one input feature attribute for the model to get a trend along with the output columns in supervised learning. So the reason that the machine is able to learn from the training data is because of underlying assumptions that some of these input features individually or in combinations have an impact on the output column. So there are the many applications learnings like if any particular customers would buy the product or not, if the visitors would click on ad or not, if the person would default on the loan or not, there are expected sales price of a given property, and if a person has malignant tumors or not. So all these like above are the some applications of the supervised learning, and there are the many more, so many. So the methodology that is used sometimes varies based on the kinds of output the model is trying to predict. So if the target label is categorical types, then it falls under the classifications category, and the target feature is numerical value, and it would falls under the regressions category. So the some supervised machine learning algorithms we have. So let's try to erase first. Okay. So some supervised machine learning algorithm, like it's one of these algorithms, supervised machine learning algorithms. One is the linear regressions. Second is logistic regressions. It's a second. Regressions. And third is the SVM, support vector machine. Support vector. And fourth is naive Bayesian classifiers. And fifth is decision tree. And sixth is ensemble methods, right? So it's a, you can say, so these are the algorithms. So let's see the another property of the supervised learning is that models perform and can be evaluated based on the types of model like classifications, regressions, and time series. The evaluation metrics can be applied and performance results can be measured. So this happens mainly by splitting the training data into the two sets like train sets and validation sets, and training model on the train sets and testing its performance on the validation sets. So just write the label outcomes for the validation sets. So then we can make a change in the hyperparameters. It's a converted later, we will discuss in the later. So first we will try to introduce the feature, and using the feature engineering improve the performance of the model. Similarly, the unsupervised machine learning, just we train models on the similar sorts of the data, except for the fact that this data set doesn't contains the level or outcomes target columns. So essentially we train the model on the data without any answers. So in a unsupervised learning, the machine learning try to find a hidden pattern and useful signals in the data that can be later used for other applications. And then after that, just we are also use the number of algorithms used in the unsupervised learning, like a clustering algorithms like a k-mean and hierarchicals. And second is the dimensionality reductions techniques, topic modelings, association rule mining. And then semi-supervised means both are the combined, super means supervised and unsupervised. And then after the reinforcement, it's the last time, means it's a one of the machine learning. This is a big research area in itself. And so let's try to we discuss. But now we will go in the deep. So first we try to focus more on the building the machine learning models using like a PySpark. This the main difference between the other kinds of the machine learning and reinforcement. So let's we try to start like a PySpark. So first, PySpark means there is some steps to a process and a message data using a PySpark. So let's go here. This is the platform. So I am using a basic PySpark. So let's go here. It's the PySpark. Yes. Spark practice. So PySpark. So let's see. It's a PySpark, and I want to apply like I want to take some specific data from the. So first we will import a PySpark. Let's see. First pip install exclamations, pip install PySpark. It's a PySpark. So it's a PySpark. So most of the time we will try to learn these 4 and 5 steps before collecting a data. So let's yeah, it's take us some time, so don't worry. We need to wait few minutes more. So I think it's has been. So look here, it's a metadata and it's done, so you can read the building the wheels and collected the package like a PySpark. It's called a package, and we are installing on the Python platform. So I think it's done. Now after that we will try to. So it's a PySpark. So if you want to see the version, so you can write here the Spark versions, and we start like creating the PySpark session object first in order to use a Spark. So let's see, from PySpark, from PySpark dot SQL import Spark session. session, right? So from PySpark.sql, like a Spark sessions, and then we create like a some name like a Spark. Let's write here SPARK. It should be equal to Spark session, because it's a, you can also use like a Spark session, it doesn't matter, but it's a good to, you can create the some buildings apps name. So a Spark session dot building is a very important. It's a building, it's a builder, not a builder dot app name, and we are using like a data processing, so otherwise we can use anything here. And dot get or create, it's a dot get, and O should be a capital, so or, and it's a create like a C as a, yeah, it has been, I think it should be created. Yeah, right. So it has been, data has been created, and now I can create, I need the data, so we will take a df should be equal to, like we want to spark dot read dot csv. So spark dot read, and it's a dot cs, and now you can take a view. So I need the simple data dot csv, so let's see if we have, otherwise we will take a simple data underscore csv right here. Otherwise, let's say I have a file, so I can check, do we have a simple data? I am checking. No, we don't have, don't worry, just I am going to the import here, sample, simple data underscore, it's a data and csv form. So many simple data, so don't worry, it's a Google search. Yeah, it's a, yes, we have simple data and abc, and like this learn a pandas data frame, so each panda have a simple data. So let's this, you can input this data. Yeah, so go here, sure. Yes, how do we take this data? So it's a very simple way we can, one of the way we can install, and other way just I am telling you how to take a data. It's a data, it's a data, I think, yeah, it's a csv form. Look here, data and the csv form, so we can install this data like it's a data. And do we have any installations file? Okay, subject, Yeah, don't worry, just we have a data. So I think let's take it. I have already done. So this is a process. So let's go here. I'm going to open. I have done the practice. So it's a simple data PySpark. Look here. We have already collected some basic data, so don't worry. So I do the some only the practical. So yeah, let's see. Just I have installed and I have created a PySpark and something like a import. Let's see just. So pip install a PySpark. Just I have discussed with you, and we have created the PySpark session, and now we need to import some more library like SQL. So from PySpark.sql we have already imported, and like from PySpark.sql functions as a f, and from PySpark SQL types, because there are a different type of the SQLs. So it's a we will try to import all these three. So let's look here, take a 1 minute. And after that we collected like a cloning the data. So I write here like a exclamation sign. It's a exclamation sign like this, and a git clone. So I am cloning this data like this. So look here, if you go here like copy, yeah, you can write because you don't have, and write the on the GitHub. Like I am searching here. So this one, yeah, this is the name of this site. So we can see here and go here, and it's a clone this code, copy here, and then you paste here, right? So I have done it's like this, and this one is already I have created in the few minutes back. Just it's a running. Yeah, it's a I have imported both of them, and then we are taking a data from the GitHub. So I am taking it's a data from GitHub. I hope it's clear now, but I think there is the multiples of the data. So I need a data from the data processing and the simple data CSV. So where is existing this data? So I create here the df will equal to spark.read CSV, and go here, and then we can see your data like a data processing and simple data. It's a chapter number 2, and go in the site, it's a simple data, and copy path here and then paste here. So just I have already pasted. Now we can see my data has been it's coming, but you have gotten the one problem, just you can't see your original data's header. So you need to the write here header will equal to true and info schema will equal to true. Then we want to see here my header will be C, otherwise you can see the C underscore 0 1 C underscore 1. So it's a confusion. So you must write here header will equal to true and info schema will equal to we will try to. So it's a let's see my data here, but I want to see like a length of this column. So it's a you can see the length is a 5, And what is the print schema? So if you want to see the all columns, so number of the ratings integers nullable true, and ages integers nullable true, experience has been given, family is the another columns, and mobile is the other columns. And if you want to see your data it's this way, so you can see your data ratings has been given, the specific integers, ages has been given, experience, family, and mobiles. Now select the only the base specific columns, if you want to select two columns, so df dot select methods it's a similar to the SQL, and you can age and mobile, yeah, any other columns, it's a basic command, so you must, if you have load a SQL. And in the df dot describe, it's similar to the previous data I have already done, but if we are doing in the PySpark dot SQL, so you can see that your interfaces look like a similar to the SQL, because we are using the SQL. And so like your df dot with columns, I want to the a age after the 10 year, and we are going to the describe the age column. Just I am going to the describe here the age column, so we can see here it's easy to describe a age column. So it's we can see, so we have a new columns in the data frame, and the sort functions help us to view the new columns value, but in order to edit the new columns of the data frame, so we need to edit the other a dot plus. If you want to filter your data, so let's see, it's a filtering your data. So df dot filter and mobile, we will show object attribute and filter is not showing, so I think you need to the we need to the import from PySpark SQL types, import the string types and the double types. So now it's right here, now it's easy, and it's getting the some problem object has no attribute filter. So what's happening? Sometimes we have getting a problem, but not okay, it's good, it's a filter is the basic. Why it's not working? We are getting a problem a non type object has no attribute, so filter is not working. Sometime internet is not working, so don't worry. So it's I have done each and everything. Look here in the filter.df mobile, we go filter df and experience. So it's something is wait why I am, it's a df will equal to this, so we have created a new variable like a df. So yes, I am getting a problem, so let's see df. So first I need to run df, because your original data is here, and now I go here, now it's working. Now let's see here, because yeah, here filtering a data, now it's working, because we have created the new df, it's only the age, so now it's working here. So df dot filter methods, so filtering records, it's based on the conditions is the common requirement when dealing with the data. So this helps the cleaning the data and keeping only the relevant records. So filtering in a PySpark is a pretty straightforward, and we can run the filter functions. So it's a filter functions. So first conditions we have done already, the most basic type filtering basics, only the one columns and other columns. So next conditions just we have already discussed about the multiple columns based filtering and returning the records only if all the conditions are met. And after that, so if we have like a distinct value in columns, like if you want to a distinct value in the any data frame column, so we can use the distinct method. So let us view the distinct value like this. Yeah, it's a distance value look like this. Yeah, so look here in the mobile, so you can see the different types of the distance value for the mobile columns in the data frame. And another is the grouping data. Grouping is the value useful way to understand various aspects of the data sets. So it helps to group the data based on the column value and extract insights. So it can be used with the multiple other functions as well as. So let's see the example. It's a grouping data. So df dot group by mobile count order by count ascending orders. If you want to the descending order, you can put here. Let's look here. So if you want to write here, like if I write true, so your ascending will be converted. So by if you want to get only the mean of this group, so it's a way to we can find the mean and medians and other values. So you fix your parameters according to your requirement. Then after that we will try to understand like aggregations. So aggregations, like we can use like aggregate functions as well as to achieve the similar kinds of results. It's we have already discussed above as above. So aggregations functions in a PySpark is simply taking the sum of total experience for each mobile brand. So it's the same way. It's you can see here aggregations functions. So like this, the mi average is here, Oppo and others. So I hope we are simply use the aggregate functions and this part, this column and experience we want to the aggregations to be done. And now after that, just UDF is UDF means user defined functions. So user defined functions is a widely used data processing to apply the certain transformations to the data frames. So there is the two types of UDF is available in the PySpark. One is the conventional UDF and another is the pandas UDF. So the pandas UDF are the much more powerful in the terms of the speed and processing time. So we will see how to use the both types of UDF in PySpark. First we have import the UDF from PySpark functions. So let's see the from PySpark SQL functions import UDF. So now we can apply the basic UDF either by using the lambda or typical Python functions. So the traditional Python's functions we can use like this way. This is the UDF. So define the price underscore range brand. If brand in the Samsung and Apple returns the high price, if else brand and equal to mi returns mid price and else this one. So it's a simple Python. So brand and UDF, right, and this functions has been So it's a UDF, brand UDF, and uses these functions also the capture. It's a data types apply these transformations on the mobile column. And the next step we will apply the UDF to the mobile columns and data frames to create the new columns price range. So I think just you can see that's a UDF, and then it's a something you can see here. Yeah, we can see the price range is the you have new columns has been created. So I hope. And another, just using the lambda functions instead of the defining the traditional Python functions, so we can make use the lambda functions. I have already applied this number of times to create the UDF in the single line of the code and shown this is the categorize the columns into the two groups, young and seniors. So if you try to use, so you can use these functions like a lambda functions is also like. So it's a good to you can try, and its age groups has been converted like a different. So I hope till here you can understand. And it's a pandas UDF, it's a like a vectorized UDF. So like mentioned earlier, the pandas UDF are the way the faster and efficient compared to their peers. So there are the two types of the pandas, one is the scalar and another is the group math. So using the panda UDF is a quite similar to using the basic UDF. But we have the first like importing the panda UDF. So let's say import a panda UDF like from PySpark. So you can write here from PySpark .sql .functions import pandas underscore UDF. Right. So we define the Python functions and calculate the number of years left users assuming the life experience of the 100 years. It's a very simple calculation, and we subtract the age from the 100 and using these functions. So it's a one of the best way we can analyze like the columns like a diff remaining underscore years like years, and we can put the parameter like a age, and after that slicing we are putting here and years underscore left will equal to 100 minus age, 100 minus, and return it's a returns yrs underscore left left, it's a left, and then you can see here underscore it's a years left. Okay, so let's see here it's a I think YRS, it's a invalid. YRS, yeah, it's a Y, not a years. It should be the YRS. It's a what happening? It's a YRS. It's a YRS. Return, not returns. Yeah, it's a working. Look here. And now I want to the print something like a length underscore UDF, length underscore UDF should be equal to pandas underscore UDF remaining underscore years underscore years integer type. Integer, sure. So once we create the pandas UDF length underscore UDF using the Python functions remaining years, and we can apply the age columns and like create a new columns here like this. So let's see df dot with columns with column, and just I want to put here years underscore left YRS underscore left, and its length should be length underscore UDF and DF like a age. Dot so, and it's parenthesis. So you left, okay, so I think df dot with column, okay, here left length underscore UDF df and age, okay, so age should be like this. It's a string. So yeah, let's, so it has been created like this. It's a year the left. So I think just panda UDF, and we can also create like a multiple columns, the ones. So if you want to the drop or duplicate value, it's a df dot duplicates and delete these columns. So df dot drops we can easily delete. And other we can also, we are writing a data like a CSV, so PWD we will apply here, and then PySpak says the data set, the huge if you have a huge data sets that it's involved a lot of the columns, so we can choose the compressed it, the convert into the PySpak file formats. So these are the basics, and I try to share with you. So I hope it will helpful, and next class I will try to do the something new, like how to apply linear regressions with the PySpark. So thank you very much.